So now we are on to section 10.7, and 10.7 is inscribed and circumscribed polygons. So when I tell you a polygon is inscribed, you can think of it as inside. I can also tell you that a circle is inscribed. So the word inscribed just means inside. It also means if a polygon is inscribed that all of its vertices, these pink points, are on the circle. Okay, so this is an example of an inscribed triangle. If I was to tell you a polygon is circumscribed about the circle, that means that each of its sides are tangent to the circle. And what that does is it creates a bunch of tangent ice cream cone problems. Okay, so again, if I said that, this pentagon was circumscribed about, and last one, about the circle, circumscribed about the circle, keep in mind that that means that each of these sides are tangent to the circle. That also means if you're to connect the radius to it, keep in mind that it's going to be perpendicular to those points of tangency. Okay, so it's perpendicular to the points of tangency. And then next, if a quadrilateral is inscribed in a circle, so let's draw any quadrilateral in the world. And again, I'm just drawing some obscure quadrilateral. I'm trying at least, and it's not letting me. No, I don't want to do that. I wanted my other one. I wish there was a pause button. You guys fast forward, hopefully. Okay, so I just have some obscure quadrilateral, not a rectangle, just any quadrilateral. Look at the opposite angles, you guys. This angle right here, okay, is technically inscribed. This is an inscribed angle, and it's using this blue arc right here. Okay? And then if you look at your other angle, the opposite of this blue angle, so this pink angle right here, this pink angle works with this arc. Okay? So, because these opposite angles create 360 degrees, the opposite angles, because they're inscribed, have to be half that, or 180 degrees. Okay, so again, opposite angles. If you have a quadrilateral, any quadrilateral in the world, inscribed into a circle, the opposite angles, okay, so if the quadrilateral is inscribed in a circle, then the opposite angles have to be supplementary to each other, the opposite angles. So that is also true for angle B and angle D. Okay, and then we have a lot of information about, a parallelogram. So if I have a circle, if I asked you to draw a parallelogram in a circle every single time, and this is crazy, hopefully you guys are, you take a circle like this and you try to draw a parallelogram. So the first thing I would do is I would draw the parallel sides. So obviously you have to make these sides parallel. So let's make our chords parallel. When you go to connect the other sides, every single time it makes a rectangle. Trust me, I tried. I was like, okay, so let's draw maybe them really close. Let's draw two parallel sides that are really close. If those are parallel, then the other sides, and it ends up being a rectangle no matter what. Okay, so if you have a parallelogram inscribed in a circle, it's a rectangle. And then here's some things that you can pull out from it. So if ABCD is inscribed and it's a parallelogram, then BD and AC not only are congruent, because in a rectangle diagonals are congruent, but they are also diameters, which means they go through the center of the circle. They also create, semicircles, and look at the arcs and all that good stuff. O is the center of the circle, obviously, we just said, because the diameters, those are diameters. All of these segments are equal, okay? OA, OB, OC, and OD. And that's because a parallelogram, the diagonals bisect each other, and in a rectangle, the diagonals are congruent. Therefore, all those pieces have to be congruent to each other. And then also, because, like I said, we're creating these semicircles, okay, Okay, these angles have to be 90-degree angles, again, because it's a rectangle. So if you think about it, AB squared plus BC squared has to equal AC squared. You also have a bunch of other right triangles that you can pull from this, okay? So as soon as you see them saying a parallelogram is inscribed in a circle, ignore the word parallelogram and replace it with rectangle. So you know a rectangle is inscribed in a circle, okay? And that is all we have for 10.7.